So today we're going to learn slopes of secants and average rate of change. This is lesson 7 of unit 4. So first, let's have a look at today's learning goal. After this lesson, you should be able to understand that the rate of change is a measure of how quickly one quantity, that is the dependent variable, changes with respect to the other quantity, which is the independent variable, and understand and interpret the concept of average rate of change. Calculate average rate of change from a graph, a table, or an equation of a function. So first of all, let's have a look at the concept of the average rate of change. The average rate of change between 2 points corresponds to the slope of the secant between the 2 points. For example, suppose we have a function whose graph like this. The average rate of change of y with respect to x between the points p1, which is here, and p2, which is here, is determined as follows. First, let's suppose p1 has coordinates x1 and y1, and p2 has coordinates of x2 and y2. Then the average rate of change is defined as delta y over delta x, which means the change in y over the change in x, which is y2 minus 1 over x2 minus x1. Understand? And from the graph, we can see that is actually the slope of the secant line between P1 and P2, right? Okay, so this is a brief concept of the average rate of change between 2 points. Now let's use some example questions to illustrate these concepts. First, let's have a look at this question. So this graph represents the amount of money in the bank account over 1 year period. The x-axis represents time in months, and the y-axis indicates the amounts in dollars. And you are required to answer the following 3 questions. Okay, so first I'll give you 10 minutes to have a look at this example question. Then we'll have a look at the solution together, okay? All right, let's have a look at the solutions together. First question, how many was in the account at the start of this year and at the end of this year? So note here the first point on the graph is here, which is 0, 500, right? And the last point is here, which is 12, 200. So that first, the initial amount of money is 500, and the amount at the end of this year is 200. Then question B, what does the graph tell you about the average rate of change of the amount of money in the account in the following intervals? 1, from month 0 to 5. So from 0 to 5 is this section, right? So between month 0 and month 5, the graph is a line with positive slope. The average rate of change is constant and positive. The amount of money in this account is increasing by the same amount each month. Next, from month 5 to month 8, that is from 5 to 8, which is this section, right? So between month 5 and month 8, the graph is a horizontal line with 0 slope. The average rate of change is 0, and the amount of money in this account does not change. And then from month 8 to month 12 is the last section, right? In the last section between month 8 and month 12, the graph is a line with negative slope. The average rate of change is constant and negative. The amount of money in this account is decreasing by the same amount each month. Okay, and then let's have a look at question C. Determine the average rate of change for the time period in part B. Interpret these values for this situation. So first of all, in the first section, that is from 0 to the 5th month, the average rate of change is the change in amount, which is 1,000 minus 500, over change in time, which is 5 minus 0. So the result is 100, right? That means the amount of money in this account is increasing on average by 100 per month in the month 0 to month 5. And then from month 5 to month 8, the average rate of change is delta y over delta x, actually delta t, right? Delta y is 1,000 minus 1,000, which is 0, and delta t is 3. Therefore, the average rate of change is 0. That means no change occurs. The amount of money in this account remains the same, right? And for the last section, that is from month 8 to month 12, the average rate of change is 200 minus 1,000 over 12 minus 8, which is minus 800 over 4, which is minus 200. That means the amount of money in this account is decreasing on average by $200 per month, right? So these are the interpretations of average rate of change to this particular problem. So please have a look at that and let me know if you have any questions, okay? So basically this question shows us how to calculate the average rate of change from a graph of a function, right? Next, let's have a look at an example of how we can calculate and interpret the average rate of change from a table of values from a function. Okay, so a new antibacterial spray is tested on a bacterial culture. The table on the right shows the population P of the bacterial culture T minutes after the spray is applied. The question is to determine the average rate of change of the number of bacteria over the entire time period shown in the table. Interpret this value for this situation, and then compare the average rate of change of the number of bacteria in the first 3 minutes and in the last 3 minutes, explain any similarities and differences. Okay, again, I'll give you 5 minutes to think about this problem by yourself, and then let's have a look at the solutions together. Okay. All right, let's have a look at the solutions together. First, from the table, the points are 0, 800, right? This is the initial point. And the last point is 737, right? So the average rate of change in the entire period is delta P over delta T, right? Delta P is 37 minus 800, and delta T is 7 subtracted by 0. That means minus 763 over 7, which is minus 109, right? So the conclusion is during the entire 7 minutes, the number of bacteria decreases on average by 109 bacteria per minute. Okay? And question 2, from the table, we know that the endpoint of the first interval are 0, 800 and 3, 7, 3, 7, right? So the average rate of change over the first 3 minutes is 737 minus 800 over 3 minus 0, which is minus 21. And for the last 3 minutes, that is from the 4th minute to 7th minute. The average rate of change is delta P over delta N, which is 37 minus 652 over 7 minus 4, which is minus 205, right? So that means during the last 3 minutes, the number of bacteria decreases on average by 205 bacteria per minute. So the similarity is the average rate of change in the number of bacteria are decreasing. The difference is the average rate of change of decrease is greater in the last 3 minutes than in the first 3 minutes. This may be because more bacteria are exposed to the spray as time passes, right? Okay, so please have a look at the solutions and let me know if you have any questions. And if not, let's have a look at another example problem. Example 3, calculate and interpret an average rate of change from an equation. So this time we are given an equation, which means the height of a football that is kicked into the air in terms of the time t in seconds. So determine the average rate of change of the height in the ball for each time interval. First, from t to 0.5, then from 2 to 2.5. Okay, again, I'll give you 5 minutes to think about this question, and then we'll have a look at the solutions together, okay? Okay, let's have a look at the solutions together. First, you can use this equation to determine the endpoints corresponding to each interval, right? So for the first question, from interval 0 to 0.5, substitute d0 to find the height at 0 seconds, where h0 is 1, right? And then substitute t is 0.5 to find the height at 0.5 seconds, which is 6.775 meters. So the average rate of change is delta H over delta T, which is 6.775 minus 1 over 0.5 over minus 0, which is 11.55. So the average rate of change of the height of the football from 0 seconds to 0.5 seconds is 11.55 meters per second. And using the same method, we can also calculate that from 2 seconds to 2.5 seconds, the average rate of change is minus 8.05 meters per second, right? Also, usually you can use this expression. Delta H over delta T is H2 minus H1 over T2 minus T1, right? So instead of calculating H1 and H2 first, we can just substitute H2 is actually minus 4.9 T2 square plus 14 T2 plus 1, right? And then minus 4.9 T1 square plus 14 T1 plus 1 over T2 minus T1, right? And we can just simplify this expression first, which gives us 4.9 T1 square, minus 4.9 T2 square minus T1 square plus 14 T2 minus T1, right? And over T2 minus T1, which is minus 4.9 T2 plus T1 plus 14, right? So in this way, we can just calculate T1 plus T2 first, and then plus 14. Sometimes this method can make your calculation much easier, right? So instead of calculate H2 and H1 first, you can just keep the expressions of T1 and T2 in this function, and then simplify this expression first, and then substitute T1 and T2 to get the final result of the average rate of change. Understand? So you can choose either method. Okay, so let's make a summary of today's lesson. So now you should be able to understand that a rate of change is a measure of how quickly one quantity, which is a dependent variable, changes with respect to another quantity, which is an independent variable. And also understand and interpret the concept of average rate of change. And calculate the average rate of change from a graph, a table, or an equation of a function, okay? So this is what we have learned for today. And the rest of the time, you can download and complete today's homework. And do remember to submit your solution onto Google Classroom before the deadline, okay? You can start doing your homework now.